This video we're going to look at equations of linear motion. Okay, just a little question about using these derived equations for the motion of a projectile in Earth's gravity. Okay, let's just make a question up. Let's look at it like this. Let's make a metric. Let's say this. Let's put a building like this, and that's the ground. Okay. And let's put a ball here, and the ball initially goes straight up, okay, with a velocity of 2 meters per second. Okay. The question is, how long does it take till it lands? Now it goes straight up. I'm going to actually draw a little bit of an arc just so I can make my drawing work, but it's going to land vertically down here. Okay. I think there's two good questions here. What's V final? And what's the time, the flight time? Okay. Let's make this building height 10 meters. So you're standing on top of a building and you launch the ball straight up at 2 meters per second. Right off the bat, okay. This question, it's difficult to take your eyes off of this trajectory. Even if it's going straight up, it would be maybe a bit more interesting or challenging if the ball was thrown at an angle, because then it would have that nice arced path. But regardless, the application of these equations right here, I'm just going to look at these three right here, okay? They are only looking at the initial, or one event and another event. The path, the flight path is not, the flight path is an equal sign if you want to think of it that way, but basically it's saying just concern yourself with what's going on at the initial point and what's going on at the final. Okay, direction, velocity, so on. In other words, take your eyes off the top peak thing. That might be another question. The other question might be, how high does it rise? I didn't ask that question though, so you don't even need to look at that. You can do it by accounting for that maximum height and then the drop, but it's unnecessarily complicated. Okay. I'm going to add something. This is kind of obvious, but I'm going to add this x and y. We're going to call that x, y positive, like that. Okay, so we've got three equations of motion. Now, well, you know what? Let's do this. Let's make a little grocery list, if you will. Known v initial is 2 meters per second upwards, right? Or positive, i.e. positive. Okay. Now a few things here. You got to pick a datum. Anything can be a datum. I can use the ground as a datum, but I think I'll use this as a datum. The top of the building. Maybe the ground is better. Datum 1 and datum 2. You pick one, okay? You pick one. If I use datum 1, then what I'm doing here is I'm determining what the heck is the displacement, okay? As long as you're consistent, you can choose either datum. There's an infinite number of datums. If I choose datum 1, then my initial displacement is 0, and my final displacement is going to be a negative number. If I choose datum 2, then my initial displacement is 10, and my final displacement is going to be 0. See the difference? This would be datum 1, s naught equals 0 meters, s final equals negative 10 meters. Again, it's not going to give you different math. You just have to account for things carefully. If you choose datum 2, then s original is 10 meters. It starts with a 10-meter head start, if you will, and s final equals 0 meters. Okay, it doesn't matter. I'm just saying. Okay, pick one. Okay, the only other thing we have going on here in the known column is the acceleration. If you use these, you don't have to. Well, I guess they all involve acceleration, but acceleration is negative 9.81, of course. Gravity. All right. It's always going to be negative when you choose this as your coordinate axis system. So just you got these absolutes that are not debatable. So all right, step 2. Well, I want to know V final and T. So V final. Just look at that. V final is right there. Again, forget about the arc and the flight path. Look at that. I can just use that. V final is V initial plus AT, except I don't know T, 2 unknowns. I just realized that as I wrote it. So I can't use that one. Okay. What about this one? V final, V initial. That one will work. V final squared is V initial squared plus 2AS. How many unknowns? Only one. One unknown. Can use. Okay. Now the other one is the third one, which also you can't. So you process elimination. You can't use that because it also has time in there. So let's go ahead and use that one. V final. Well, I don't know V final. V initial is 2 meters per second, all squared. Notice it's a positive number. Okay, it wouldn't matter. It's getting squared anyways. But plus 2. Acceleration, negative 9.81 meters per second squared. S. Okay. Watch out here. You'd be trying to take the square root of a negative number. You're going to blow up the planet if you do that. S is, now it depends what the datum is. I think I'll pick this one as a datum. I kind of have to. If I pick the bottom one as a datum, then I don't have the correct, right? See that if I pick the bottom one as a datum, then what the heck is S? I guess it's negative 10. That would work. Yeah. S is negative 10. Let's just, maybe I'm making it too confusing. Negative 10 meters, okay? Where does the ball end up with respect to initial location? Okay, move this up a little bit here. Notice that if I didn't put a negative there, that would be a negative number, and it would make havoc mathematically. V squared equals 4 meters squared per second squared. That's 2, right? Plus the 2 negatives make a positive. What is that? 9.81 times 10 times 2, 196.2, and that is meters squared per second squared, as it has to be because you're adding them together. Okay. So V final squared is, right, 200.2 meters squared per second squared. If I didn't have a negative there, this would have been a negative number. I would have been trying to take the square root of a negative number. So it's kind of solves it, like it doesn't solve itself, but that mistake becomes glaringly obvious when your calculator freaks out on you. Okay, so V final, obviously take the square root of it. 14.15 meters per second. Now a note here. Because this is squared, does this make sense? The value is correct, but it's a negative number. You can't, obviously it's going to be going downward, okay? So it's a negative number. So you have to account for that. Downward. Well, you have to manually, okay, account for that. All right. Second thing I asked for is the flight time. And the flight time, clearly you can use a number. Well, you can use either equation. Whichever is easier, eh? Clearly, the first one's easier than the second. In fact, I'm going to squeeze it in here. Why not, eh? Step 3, flight time. The equation is V final equals V initial plus AT. Well, V final is negative 14.15 meters per second. V initial is 2 meters per second in the other direction, positive, plus negative 9.81 meters per second squared times T. T equals. Again, if you get wrapped up in negatives and you have to do some, cancellation on you're not doing it right. If you have a negative that you can't handle there, you're not doing it right. This is negative 4, here it is here. 14.15 negative minus 2. All right, so both sides of the negatives cancel out. Okay, divided by 9.81 negative. Flight time 1.646 seconds. I wonder if that's 1.65 seconds. Okay. Yes. You could actually double check your work by using the third equation, this one. Okay. So 1.65 seconds. One more time. That seems short to me, but it's barely moving, and it's only 10 meters off the ground. Okay. 14.15 negative minus 2 equals divided by 9.81 negative 1.65 seconds. Okay. Sure, 2 meters per second is nothing. That's just barely tossing it off the top of the building. Okay. All right. So just watch. You've heard that before. Watch the negatives. Yeah. Indeed.